Throughout this series, we've made it a point to just ignore error handling so that we could focus on encoding and decoding. But as you might have realized from the number of times we typed out that exclamation point after the try statement, there are several places where encoding and decoding can go wrong. Codable breaks up errors into two types: decoding errors, defined by the decoding error type, and encoding errors defined by encoding error. Now this is better than one catch-all type because that would mean having to catch every kind of error, regardless of whether we're serializing or deserializing. In practice, that would mean that developers often just write one generic catch statement or ignore errors altogether. We have some experience with decoding error. In an earlier video, we ran into a situation where a key we were looking for may not have existed, and instead of force unwrapping that coding path, we threw an error. Decoding error is not a complex type at all, and only defines 4 types of errors. So the first one is data corrupted. This error is thrown when the data is corrupted. Now, if you run into this error, there's a high chance that your JSON is not valid. In your project playground, navigate to the error handling page if you downloaded the project, or grab the code snippet from the links below. In here, we have some very basic starter code. We have some sample JSON, a type that conforms to codable, and a decoder. So let's try to decode this JSON into an instance. The correct way to do this, in contrast to the way we've been doing it all along, is to use a do, try, catch statement since these are all throwing operations. So we'll say do let user equal try decoder.decode user.self from JSON. And then we'll include a generic catch block and we'll print the error. The decoding operation should fail, and in the console you can see the data corrupted error. The decoder took a look at our JSON, and since it didn't begin with an array or dictionary, it considers it invalid and throws the data corrupted error. If we got this JSON directly from a server, then this situation is out of our control. Now the JSON string that you see in this playground right now is actually valid JSON. If you go back down to the error and inspect it further, you'll see that we have the data corrupted error, but then we also have some more information, a lot of it actually, and here there's a value called underlying error, and we see a code of 3840 for NSCoco error domain, and a description saying that the JSON text did not start with an array or an object. Now read object as a dictionary. In addition, it says that the option to allow fragments is not set. This underlying error is again specified in a user info dictionary, so it tells us twice that we didn't start with an array or dictionary, and we did not allow fragments. So there's a lot going on here, particularly with these nested error descriptions. Let's peel things back a bit. This is really the only complicated error that you might run into. As is often the case, since Swift is relatively new, particularly open source Swift with some of the newer foundation types, a lot of this code is actually relying on existing functionality to get the job done. At the very start of this series, I mentioned that Codable and its related types allow us to bypass NS-JSON serialization to encode and decode JSON. That wasn't entirely true. Before we got Codable, we got a Swift version of NS-JSON serialization, JSON serialization, that lets us parse JSON much like we did in Objective-C, but with a more Swift type. Codable and its related types still use JSON serialization under the hood. And while this isn't a Coco type, it still implements some of that functionality and returns some of its error messages. One of the things we could do with NS-JSON serialization and JSON serialization was pass in a set of options when decoding that informed the parser about how the JSON was structured. One of those options was called allow fragments. So we can actually do that over here. So I can see let, we'll just say value for now. We'll say JSON serialization dot JSON object with data, and we can pass our data object here. And in this options field, it takes an option set. Here we can say allow fragments. So what this tells the parser is that JSON may not be structured at the top level as an array or object, but go ahead and parse it anyway. So that's what allow fragments not set means in this error message in the console. Unfortunately, while JSON decoder uses JSON serialization under the hood, and that's why you see all these error messages, it doesn't expose the ability to turn on or off the allow fragments flag. So while technically this is valid JSON that we should be able to parse, we cannot do it if we're using JSON decoder. So that's what all these error means. But we can change this up. So let's use a dictionary and we can say ID of 10. And now it should parse it perfectly okay. And we should have a valid type. There we go. Okay, so the remaining decoding errors are pretty straightforward. Key not found indicates that a key that we're searching for was not found in the JSON structure. This can occur in 3 ways, all of which we have covered so far. So first, the key exists, but there's a mismatch between the string representation of the key defined through our coding key conforming type and the actual JSON. We can resolve this by either specifying convert from snake case at the decoder level or implementing a custom coding key conforming type where we have more control over our key specifications. The second situation you might run into is one where the JSON response from the server includes the key only some of the time. When it's not specified, unless you handle it, you'll run into a key not found error. You've seen this before. You would handle this situation by asking the decoder to only decode if present. Lastly, you might run into a situation where the key actually doesn't exist, which would mean you need to change your model. The next error that we can run into is a type mismatch error, and this occurs if you're trying to decode into a type that does not match what the decoder expects. So let's say the decoder can convert to an integer value, but you're asking it to convert it to a double value. That wouldn't work, or a string and int. And lastly, you can run into a value not found error, and this is simple. We would model this with an optional type. So that's all there is to decoding error. One thing you will notice, though, is that each enum member, so let me go back here actually to Codable. We'll navigate through to that type. And if we go to Decodable, actually, let's go to the decoder. You know what? I'm just going to hit Command F to find, and we'll look for decoding error. Wow, okay, never mind. Okay, it's mentioned 224 times. So we'll ignore this. Let's go to Help, Developer Documentation. And we're going to look for the decoding error type. There we go. And if we look at this type, we'll notice that all the enumeration cases includes as an associated key at minimum. So some of them have more than one, but at minimum, all of them carry an instance of decoding error.context. So this bit is a bit important. So let's inspect this value a little more in the next video.